Moving on to question 3b, we're going to start the same way with finding the oxidation numbers of everything that is present. So this is 0, this is positive 2, sorry, that's positive 4 and negative 2. This is positive 1, positive 6, negative 2, and this is positive 2, positive 6, and negative 2. All right, so I think this is a situation when you get the same product from both oxidation and reduction. So PB has an increase in oxidation number from 0 to positive 2, which means that it is the reducing agent, as there is an increase in oxidation number. PbO2, so the lead in PbO2 has a decrease in oxidation number from positive 4 down to positive 2, so it is your oxidizing agent. Okay, so I have identified the oxidizing and reducing agent. The question indicates that this is an acidic condition, but even if it doesn't, you should be able to tell by the presence of sulfuric acid, which is an acid. And before I actually do the question, I'm just going to quickly check whether I could split anything. Lead is a solid. This is an ionic compound, but unfortunately it's also solid, so I can't split that. Cannot split. However, sulfuric acid is a strong acid, so you should be able to break that into H plus and SO4 2 minus, which makes it easier for you to balance. It just means that you have a solution of sulfuric acid present, and PbSO4 is an ionic compound, but it's also solid, so I also cannot split it. Okay. So I'm going to do the half equations. For oxidation, there is a reducing agent, so what oxidation is going to be Pb going to PbSO4. You have to keep the whole ionic compound because it's a solid. So I would start by trying to balance the SO4, and because there are SO4 ions floating around in this solution from H2SO4, I'm just going to add an SO4 2 minus here so that it is balanced, which means that I do need to add 2 electrons on this side so that the charge is balanced, which also agrees with the fact that the oxidation number increases from 0 to positive 2, hence 2 electrons must be lost. Okay, excuse me, so that's the oxidation. For the reduction, we're going to have PbO2, solid, going to PbSO4, solid. So once again, I'm going to start by balancing the SO4. You definitely can balance the oxygen by adding water, but you can't really balance the sulfur any other way. So I'm just going to start by adding an SO4 2 minus on this side, so that sulfur is taken care of. And now I'm following cohes again. Lead is already balanced anyway. So I have an extra 2 oxygens on the reactant side, so I need to add 2 H2O, which means that, oh, I keep having to move this, which means that I need to add 4 H plus, and I think we're going with 2 electrons. So that's AQ, and that is water, liquid, which also agrees with a decrease in oxidation numbers of Pb from positive 4 to positive 2. Now this one works out quite well. You already have the same number of electrons on the oxidation and reduction half equation, so I don't need to do anything before I add them together. Although I think you're going to be able to combine a few things. So Pb plus PbO2, also solid, and we have 2 SO4 2 minus, aqueous, followed by 4 H plus, aqueous, and the products will be 2 PbSO4. You definitely won't get away with writing PbSO4 plus PbSO4. That just looks ridiculous. And 2 H2O. Okay, do a quick charge check. 4 plus, 2 times 2 minus is 4 minus, so the overall charge on the left side is 0, and the overall charge on the right side is also 0. And that's question 3b.